In this video, we will discuss the concept of converting recurring decimals to fraction with the help of these three examples. Now, before proceeding for the concept, the first thing we need to discuss is what does this recurring decimal means? You may have came across these types of fraction, like if you have 1 over 2, which is 0.5. If you have 1 over 4, that is equals to 0.25. Or you may have come across like this, if it is 3 over 8, then it will be 0.375. Since all of these decimals stop after some digit, so these are called terminating decimals. Terminating decimals. You may have also come across these types of fraction like 1/3, which is 0.333333333 and so on, never ending 3. Or you may have come across 1 over 6, which is 0.166666666, never ending 6. Or you may have came across 123 over 999, which is 0.123123123 never ending this pattern. Since these digits do not terminate and keep on repeating, these are called recurring decimals. And we need to convert these recurring decimals to fractions. This is what we need to discuss in this video. Now for that, you must know this, since the only digit 3 is repeating here, so I'll be writing it as 0.3 dot. This dot will represent or tell me that which of the digit will repeat. In this particular case, since only 6 is the digit which is repeating, so I'll be writing it as 0.16 dot. And in this case, since 1, 2, 3, 1, 2, 3, all the three digits are repeating, so I'll be writing it as 1, 2, 3, and I will put dot at 1 and 3, which will tell me that from where till where the pattern is repeating. Now let's discuss the concept with the help of this example. The first question says that write 0.3 as a fraction, give your answer in the simplest form. Since now the dot is at 3, so what I'm going to do is I'll be writing this as x equals 0.333333 and so on. Now, since only one of the digit is repeating every time, so I'll times this equation with the 10, which will give me x times 10 is 10x. And obviously, if I'm doing times this equation with the 10, so this decimal will go one place towards the right, and this will become 3.33333333 and so on. Now, since the digits after the decimals are same, I can directly subtract these two equations. So 10x take away x will give me 9x equals 3 take away 0 will give me 3. And obviously, since the digits after the decimals are same, so that will be 0.000000, so I'll not be writing that. Now to work out for the value of x, I need to divide this equation both sides by 9. So I'll be having x equals 3 over 9. Now if I simplify this, 3 times 1 is 3 and 3 times 3 is 9. So x will be equals to 1 over 3. So that means this 0.33333 or 3 recurring, that is equals to 1 over 3. Now let's discuss the second question. Write 0.54, and now these dots are on 5 and 4. As a fraction, give your answer in the simplest form. So the first thing I'm going to do is I'll be writing it as 0.54545454 and so on. Now, if I times this equation with 10, again this decimal will move to one place towards the right. So this will become 5.454545454 and so on. Now, if you observe the digits after the decimal, if I subtract 4 and 5, I'll not be getting 0 here. So now I again need to times this with this equation with 10, which will move this decimal one place towards right. So this will become 54.545454 4, 5, 4, 5, 4, 5, 4, and so on. Now, if you observe in these two equations, the digits after the decimals are same. So if I subtract these two equations, leaving this equation aside, 100 take away 100x take away x will give me 99x equals 54 take away 0 will give me 54, and obviously the digits after the decimal is 0. Now to work out for the value of x, I need to divide both sides by 99. So the value of x is 54 over 99. Now to simplify this, 9 times 6 is 54, 9 times 11 is 99. So this 0.54 recurring is equals 6 over 11. Now if I talk about the third question, this is one of the previous year question from higher paper. Use algebra to show that 0.372 recurring equals 41 upon 110. So again the idea is same. I'll be writing this as x equals 0.3. Now the dots are on 7 and 2, so obviously 7 and 2 will recur here. 7, 2, 7, 2, 7, 2, like this. Now if I times this equation with 10, this will become, this decimal will move one place towards right, so this will be 3.7272727272 and so on. Now again if you observe, the digits after the decimals are not same. If I subtract these two, I'll not be getting 0 here. So I again need to times this equation with 10. So again this decimal will move one place towards right. So this will become 37.272727272 and so on. Again, if I subtract these two equations, I'll not be getting 0 after the decimal. Even if I subtract these two equations, I'll not be getting 0 after the decimal. So what I'm going to do is I need to again times this equation with 10. So this decimal will again move one place towards right. So this will become 372.72727272 and so on. Now if you observe in this equation and in this equation, the digits after the decimals are same. So leaving these two equations aside, if I subtract these two, 1000 take away 10 will give me 990, obviously with x, equals 372 take away 3 will be equals to 369. Now if I need to work out for the value of x, I need to divide both sides by 990. So the value of x is 369 over 990. Now if I need to simplify this, 9 times 4 is 36, 9 times 1 is 9, over 9 times 1 is 9, 9 times 1 is 9 and 0. So the value of 0.372727272 or 72 recurring is equals 41 upon 110. This is what which I need to prove. I hope you understand the concept and the questions. Thank you so much. Keep learning.